Hey everyone, in this video we're going to be looking at rewriting absolute value linear functions as piecewise functions. So let's just dive right in. So here we've got just a basic absolute value function, linear clearly, and basically what we want to start doing is we want to start thinking about this as the fact that it could be actually expressed as two different functions, each with its restricted domain. So here, and that's basically what I'm saying here. So we've got function a, the left side, has a domain of x is less than or equal to 3. So I could think of all this as function a, where a gets everything from negative infinity all the way to including 3. And then function b can have everything from positive infinity all the way up to, but not including 3. Okay, so there's two distinct functions here. Now, because it's an absolute value function, I can just write it as a singular absolute value function. But it's an interesting thought exercise to think about the fact that, hey, I can have two distinctly different functions on a graph. Which we've seen to a certain extent in our previous classes when we were doing solutions, where we're doing systems of equations and stuff. But here, where this is different, is we've got functions actually sharing the same point. That it's two different functions that results in a continuous overall function, which becomes more important in calculus. So because of this, we can actually rewrite this absolute value function as two distinct functions using this piecewise notation. So let's just take a look and see what we've got here. So we still are saying y is equal to, and then we use these curly brackets here, these braces, and we're clarifying, okay, we're assigning two functions that are going to be used dependent on where we are in our domain. So the upper one is used whenever x is less than or equal to -1, and the upper one is used when x is greater than -1. And of course, x is real. So if you look and see what I did here, all I did was I just basically rewrote this, dropped the absolute value signs, and acknowledged that one side is positive, one side is a negative slope. And that's all we really need to do at this point. The interesting stuff comes up when we start thinking about the fact that, okay, I could have, oh, that doesn't look very straight at all. Let's try that again. Straight line, close enough. The interesting thing comes up in the fact, not just with absolute value functions, of like I can have something like a quadratic stopping and then becoming a straight line and making it continuous. So I can write this as y is equal to, and then having the quadratic up here, the absolute or the linear function down there, and having an overall continuous function. In fact, the function doesn't even have to be continuous. I can have something like this where we've got a quadratic, and then we've got some gap, and then boom, we've got some other function. And again, this becomes more and more important as we advance